A Viking navigator could find the sun on a completely cloudy day. They might have used a legendary tool, the Sunstone. It was a crystal that could reveal hidden light in the sky. The question is whether this ancient device was real genius or just a beautiful myth. We have a wooden disc carved with secret notches, and we have a clear crystal pulled from a shipwreck. These people had no compasses, and yet they mastered the most treacherous seas on Earth. They navigated by reading the color of the air itself. The answers are where Saga meets science. There are forgotten skills from the past. We might still use them today. The North Atlantic was just water and whispers, a horizon that faded into gray. Fog so thick it could take a ship for days. The sun could just be gone, a memory, and yet the Vikings crossed it. They went out there, their longships, these narrow oak ships. They didn't stay by the coast. They went into the open ocean, hundreds of miles, to places like Greenland, and then further to a coast they called Vinland. We know it as Newfoundland. We know they arrived, the settlements are there, the things they left behind, but how they got there, that part is different. That's written in riddles. They're sagas, these old stories passed down. They give hints, but not a manual, not instructions. There's a story, a hero sailing in a thick snowy haze. He looks to the sky, he uses something called a solarstein, a sunstone, and he finds the sun, finds it behind the clouds. For a long time, people thought that was just poetry. A metaphor for a leader's insight. It seemed impossible that a crystal could do that, could perform that kind of miracle. So that's the puzzle. We have the proof of their journeys. Voyages that changed the map, and we have these sparse, cryptic descriptions of their methods, what they did and the tools we thought they had. There's a huge gap between those things. To bridge it, you have to ask a question. Were the sunstones just a symbol, or were they real? A lost technology, a piece of physical genius, something that let them see what was invisible. To even start on an answer, you have to stand on the deck of a longship. You have to feel the actual problem, the one they solved every single time the land disappeared. The problem wasn't just getting across the water. It was knowing where you were out there. You needed something fixed, something true, when all you could see was ocean and sky. And on an island, Uunartoq, in these ruins of a monastery, we found part of that truth. It's a wooden disc, broken, worn down by time. At first, you'd think it's just a piece of old woodwork. But then you look, around the edge there's a series of notches carved with precision, and right in the center a small hole. That's where a pin would go, a gnomon. This is the Uunartoq disc. It's thought to be a Viking bearing dial. On a bright, clear day, the thing was beautifully simple. You'd lay it flat, put the gnomon in, and then you'd watch. As the sun traveled, that pin would cast a long, thin shadow, and that shadow would move across those notches on the disc, following the sun's path from morning to evening. Reading those marks, a navigator could find north, south, and the exact time of day. It was a calendar, a clock, a compass, all in one piece of wood. It shows how deeply they knew the sun. They didn't just watch it, they understood its geometry. But the disk also shows a profound limitation. It depended entirely on one condition. A clear, direct view of the sun. On the right day, it was genius, but the North Atlantic isn't made of right days. It's fog, it's low, dense cloud. It's the long, gloomy twilight of northern winters. In those conditions, the gnomon casts no shadow. The notches are meaningless. The disk is just a silent piece of wood. So this object gives us two insights. First, the Vikings had a sophisticated, scientific method for navigation. And second, that method had a catastrophic blind spot. The very conditions that made their voyages so dangerous were the ones that made their best tool useless. That's the gap in their toolkit, a gap between what they clearly knew how to do and what they somehow managed to do anyway. if the sun was hidden, how did they still find their way? The answer pushes us past wood, past shadow, into the hidden nature of light itself. The wooden disc was for sunny days, but the ocean doesn't give you many of those. So the next clue, it isn't carved from wood, it's cut from light. In 2002, archaeologists were exploring a wreck, an English warship that sank in the late 1500s. Off the coast of Alderney in the English Channel, and among the cannons, the timbers, they found something small, smooth, perfectly clear, a crystal about the size of a deck of cards. Shaped into a long prism, it was calcite Iceland spar. This wasn't jewelry. It was found with the ship's navigation instruments. And even though this ship sailed centuries after the Vikings, its discovery sent a shock through maritime history. Here was a physical object, a crystal in a navigational context. It made the Sunstone, this idea from the sagas, something real, something sailors might have actually used. The Alderney crystal doesn't prove the Vikings used it, but it proves the principle existed, that the knowledge of using crystals to find the sun was known and preserved long after the longships were gone. Researchers like physicist Guy Roppars, they took crystals like this one. They asked a simple question. What can it actually do? The answer is in a property called birefringence. Calcite doesn't just let light through, it splits it. You look through a clear piece, you see two images. Hold it over a dot, you see two dots. That splitting is its secret because it doesn't just split any light. It reacts to polarized light that's been scattered and organized by the atmosphere. Even on a completely overcast day, the sky still has patches of this polarized light, arranged in a pattern around the hidden sun. To our eyes, it's just gray. But to the crystal, it's a map. Here's how it might have worked. A navigator holds the crystal up to the sky, rotates it slowly. They're watching the double image. As they turn the stone, the two images change in brightness, and when the crystal is aligned the right way, following that hidden pattern, the two images become equally bright. At that moment, the long axis of the crystal points directly toward the sun. Even if the sun is completely invisible behind the clouds, it was a way of reading the sky's hidden signature. The Alderney crystal turns the Sunstone from a metaphor into a plausible piece of technology. It bridges the saga's words and the physicist's lab. It suggests the Vikings, with their observational skills, could have discovered this property in the clear calcite from their own land. They wouldn't have called it birefringence, they might have called it magic, but the effect would be the same. A gray sky giving up its secret. The science tells us it works. The artifact tells us someone used it, so you have this convergence. The sagas mention the stone, the physics confirms the function, and from the seafloor we have a crystal that was almost certainly used for navigation. The pieces are aligning, pointing to a forgotten method, not relying on shadows but on seeing the color of the air itself. The secret of the crystal is in a light we can't see. Even on a cloudy day when the sun seems gone, its influence is still there. It's written into the color of the air in a code. That code is polarization. It's like the glare on a wet road. Sunlight hits that flat surface and it organizes. All the light waves start vibrating the same way. That's polarized light. That's why polarized sunglasses work. The lenses are like a fence. They block that organized glare from the road, letting the softer light through. The sky does this naturally. Sunlight scatters in the atmosphere. Even through clouds, it creates a pattern, a vast, subtle pattern of polarization. It's a signature to us, it's invisible. We just see gray, but to a crystal like Iceland Spar, that pattern is a clear message. The crystal is a decoder. Its structure, its atomic lattice, is a built-in filter. Polarized light enters and something happens. The beam splits. You see a double image, and this is the navigational part. The brightness of those two images changes. It changes based on how you hold the crystal, how you hold it relative to that hidden pattern in the sky. A navigator would rotate the stone. They'd watch the twin images shift. One gets brighter than the other. They were looking for the balance, the point where both images glowed the same. At that exact alignment, the long axis of the crystal points right at the sun. It reveals the sun's location behind the clouds. They weren't looking for the sun itself. They were looking for the sun's effect on the world. They read its fingerprint on the sky. This turns navigation on its head. Fog and cloud weren't just obstacles anymore. They weren't just blinding the tools. In a way, they became the medium. The medium that carried the signal. The thicker the haze, the more the light scattered, and the stronger that polarized signature could become. It was a revolutionary idea. That you could find your way not by seeing a landmark, but by interpreting the light, the hidden quality of the light around you. It suggests a relationship with the environment. A deeply intimate one, almost like listening to a whisper in a silent room. They learned to hear what the sky was saying. Of all the crystals out there, there's one that fits perfectly. Iceland Spar, it's a clear, bright form of calcite, and it has this trick with light like it was meant for this. When you look through a clear piece, you don't see one world. You see two. Put it over a dot on a page, and the dot becomes two. That's birefringence. The crystal structure splits a beam of light. For a Viking navigator, that wasn't just a curiosity. It was a compass made of light. The process, as researchers have worked it out, seems simple. On a cloudy day, a sailor would hold the spar up to the sky. They weren't looking for the sun. They were watching the twin images inside the stone. They would slowly rotate the crystal, and as they turned it, the brightness of those two images would change. One would get dimmer, the other brighter. The navigator's job was to find the sweet spot, the exact angle where both images shone with the same intensity. At that moment of balance, the long axis of the crystal points right at the hidden sun. It gives you an azimuth, a line to follow. It turns a blank gray sky into a guide. This isn't just theory. An experimental archaeologist, Leif K. Carlson, has taken replicas of these sunstones on real voyages. He describes it not as reading an instrument, but as developing a feel for the sky. It's a skill, he says. It takes patience and a sharp eye for subtle light. You're not getting a digital readout, you're interpreting a living signal from the atmosphere. And what makes Iceland Spar so compelling is it's not some rare, magical gem. It's a practical, available resource. This crystal forms naturally in Scandinavia. The Vikings would have found it, used it. They knew their land and what it offered. So you have a tool that's both deeply clever and completely local. It shows the perfect match between a people's knowledge of their environment and their ambition. They took a stone from their own ground and used it to read the sky, to cross an ocean. The genius is in that connection, seeing the extraordinary use in something the world had just left there in the light. Iceland Spar wasn't the only key. There was a second candidate, a stone with a different kind of magic, Cordierite. Some call it the Viking's compass, and where calcite splits light, Cordierite changes it. It changes color. You take this grayish-blue mineral, hold it to the sky, and rotate it slowly. If the light is polarized, that organized hidden light, the stone doesn't just sit there. It shifts. It can go from a pale, hazy yellow to a deep indigo blue. The change is direct, visceral. You're not comparing two images. You're watching one stone tell you a story through its own hue. For a weary sailor on a rolling deck, the advantage is clear. It could be more intuitive. You find the angle where the blue is deepest, most vivid, and that axis points toward the hidden sun. It turns navigation into a search for color, a quest for the deepest blue in a gray world. And this wasn't some exotic import. Cordierite deposits are found across Scandinavia. The Vikings would have known this stone. They might have picked it up, noticed its strange behavior on certain days, and through patient observation, unlocked its purpose. Some scholars point to passages in the sagas, mentions of a stone that darkens or lightens. The evidence isn't as clear-cut as for calcite, but it opens a possibility. The Vikings may not have had one single tool, one rigid technology. They may have had a toolkit, a set of principles applied to different materials. If you couldn't find clear Iceland spar, perhaps you used the color-shifting Cordierite you had. It speaks to a practical, adaptable genius. They weren't following a manual. They were reading the world, experimenting with what it gave them, and discovering the hidden rules within. This expands the story from a single, brilliant trick to a broader cultural skill. It suggests a society that paid profound attention to the subtlest qualities of light and stone, where a navigator's expertise wasn't just about memorizing stars or coastlines, but about developing a deep, almost poetic sensitivity to the materials in his hand and the sky above his head. The goal was the same, to find the sun's path, but the methods could vary, born from the landscape itself. So the question isn't just, did they use a sunstone? It becomes, which sunstone did they use today? And what does that tell us about how they saw their world? The crystal theory was beautiful, but could it actually guide a ship? That question had to move from the sagas into the lab. The legend needed the proof of modern science, and that proof came in a series of experiments. One of the most compelling was from a team at the University of Rennes in France. Physicists, Dr. Albert Lefloc among them, decided to test the sunstone principle. They set it up with precision. They put a calcite crystal inside a wooden box like a longship's deck. They used a polarized light source to simulate the sky's hidden signature. The goal was clear. Could the crystal, just moved by human hands, pinpoint a light source it couldn't see? The results were stunning. A trained user rotating the calcite, looking for that balance of brightness in the double images, could find the sun's position with an accuracy of 99%, and it worked in extremely low light. It could work after sunset, using the last polarization in the twilight sky. Dr. Lefloc noted the crystal's precision was remarkable. It rivaled a modern magnetic compass under those conditions. This was a rigorous validation. The lab evidence changed the sunstone from a speculative legend into a viable technology. The physics worked. The principle was undeniable, but a proven principle in a lab is one thing. The wet, freezing deck of a longship in a North Atlantic gale is something else. Science answered the could it question. Yes, it could work, but that raises the more intriguing question. Did they know? Did the Viking navigators, through observation and necessity, discover this hidden property of light and crystal? The lab proof gives us the mechanism. The physics behind the myth. It shows the tool was possible, but the true mystery isn't in the crystal. It's in the mind of the person holding it, staring into the gray and seeing a path home. The sagas are how we see into that world, but the view isn't always clear. It's layered with poetry. To get to the sunstone, you have to look at the actual words they used. The most well-known reference is in a short story, Roðolf's Thota. There's King Olaf who would become a saint. He wants to test the faith of a visitor. The sky is completely overcast, thick cloud. The king asks this visitor, Sigurd, where the sun is. Sigurd is a man of deep faith. He suggests they ask God for a sign. But the king has another way. He asks for a solar stein. He takes the stone, holds it up, and sees where the light comes from it. Then he points right to where the sun is, hidden. That passage is key. It's not describing a magical ritual. It's describing an action. The king uses the stone to check a fact about the physical world. The language is plain. It treats the solar stein as a known object, something with a known function. That's the strongest literary evidence we have that it was a literal tool. Not just a metaphor for wisdom or divine insight, but the Old Norse mind loved layers of meaning. Their language was built on kennings, poetic riddles. Whale rode for sea, battle light for sword. So when we read Solarstein, could it be a kenning? Could it mean something like a sure guide, a steadfast leader? Maybe, but the context argues against pure metaphor. In that story, the stone is an object you hold. You use it to find a celestial body. It does a specific physical task. That feels less like poetic symbolism, more like reporting. It reads like someone describing a compass or an astrolabe, a piece of technology so familiar it doesn't need explaining. Now contrast that with other Saga references to wayfinding. In the Saga of the Greenlanders, when Bjarni Herjolfsson gets lost, he doesn't pull out a crystal. He looks for signs in the natural world. He watches for birds. Birds can show the direction to land. He observes the color of the sea, the temperature. He looks for whales in certain feeding grounds. Those are the methods of a coastal pilot, reading living clues from the environment. The Sunstone is different. It belongs to a different class of knowledge. It's for when those living clues vanish, when there's only sky and water. It's for the open ocean. This literary trail shows something. The Sunstone isn't presented as a marvel or a secret. It's woven into the narrative as an accepted piece of a navigator's toolkit. Its appearance is almost casual. That hints the concept was integrated into their seafaring culture. It was practical knowledge, passed down not in manuals but in practice, in story. The sagas don't give us an instruction manual. Their audience might not have needed one. Knowing how to read the stone may have been as commonplace among shipmasters as knowing how to trim a sail. Its very mundanity in the text is what makes it compelling as history. It suggests that for the Vikings, finding the sun in a gray sky wasn't magic. It was just another skill. Born from a deep and relentless conversation with the light of their world. The deck was wet. The mist had been there for days. The sun was gone, but the navigator he knew would. He knew the sea. He wasn't lost. He had a pouch on his belt. Inside, wrapped in wool, was a piece of Iceland spar, clear, sharp. He held it up to the gray sky, not where the sun should be. Just a blank part. He closed one eye, brought the crystal close. The sky became two skies, two faint gray fields. He started to turn the stone slowly. Between his thumb and finger, that's the method. He wasn't looking for the sun. He was watching the light inside the stone itself. As he turned it, one of the two images began to darken. The other got a little brighter, just a shade. He kept turning, patient, feeling the ship move. Then he found it, an angle where the two glowing fields matched, where their brightness was exactly the same. In that moment, the long axis of the crystal became an arrow. It pointed a true line through the fog to the hidden sun. He lowered the stone, but that wasn't enough. Knowing where the sun was right then, that was just a snapshot. To make it a course, he had to cross-reference it. With a map in his mind, he knew the sun's road. For that time of year, he knew the arc it should make. He knew its height at noon, so he took the direction from the crystal. He noted it against the ship's heading, maybe from a shadow on the deck from a fixed staff, back when the sun was last visible. He combined the crystal's fixed point with his internal calendar. With his internal clock, was the sun where it should be for mid-morning? If it was further south than expected, what did that say about their latitude? That's where the tool went beyond physics. The crystal gave a fact, the navigator's knowledge, a lifetime of patterns passed down lore, experience, turned that fact into understanding. It was natural science and cultural memory. The crystal was the key. The mind was the lock, and in that gray, silent world, turning a stone could whisper the way home. The crystal was one piece. It wasn't the whole map. For a Viking navigator, finding the sun was just the start. That one point of light had to fit into a living understanding of the sea. They had a mental toolkit built from watching and listening. The ocean had a language. They could read the water, the pattern of the swells, the wind on the face. These weren't random. A change in the swell could mean a distant coast long before you saw it. They watched the water's color. Near shore, it might be green or brown. Out in the deep, it was a clear, deep blue. That color was a natural chart. It told you how far from land you were. They listened to the birds. A seabird, like a fulmar, flying a straight line in the morning, often pointed toward its nesting grounds. The species told you direction and roughly how many days of sailing were left. The sky, the water, the wildlife, everything was a sign. Then there was the math of the journey, dead reckoning. From a known point, the navigator was always calculating. He estimated speed by the feel of the wind and the wake. He kept the direction in mind, guided by a sunstone reading or the stars. Speed times time gave distance, direction gave the line. It was an estimate, constantly updated. It was prone to error, but it gave you a framework. The sunstone's reading would snap into that. It corrected the drift. They also knew the sun's road, its path through the year. A fixed sun compass fits here. On a clear day, a shadow board. On a cloudy day, the sunstone gave the date to point to a line with that solar calendar. And at night, the stars. Polaris was the fixed point in the north. Other constellations rose and set at known times, giving direction and a sense of the hour. So the sunstone wasn't a magic box. It was a specialized instrument in a vast system. It gave a precise celestial fix when the markers vanished. But that fix only meant something when combined with the smell of the air, the taste of the salt, the sound of the waves. It added to an understanding that was holistic and intuitive. The real navigation happened in the mind of the person who knew how to ask the right questions of the world. The sunstone theory is elegant, but it has serious challenges. Scholars who study these texts urge caution. The gap between a plausible tool and a proven one is wide. And the first big hurdle is in the sagas themselves. The references to the Solarstein are sparse. They're in only a handful of stories, and the descriptions are brief. Could these passages be symbolic, a literary device to show a king's wisdom, not a literal navigation lesson? Some historians argue yes. The sagas were written centuries after the events, often by Christian scholars. The old ways were fading into legend. The line between remembered technology and poetic metaphor might have blurred long before the stories were written down. Then there's the silence from archaeology. We have longships, tools, settlements, but we don't have a single, unambiguous sunstone from a Viking Age context. No crystal found in a navigator's kit, carved with runes or wear marks that show its purpose. The Alderney crystal is powerful evidence, but it's from a much later period, a different culture. It shows the principle survived. It doesn't prove the Vikings invented it. This absence is significant. If these crystals were central, why haven't we found one in a Viking grave or lost in a harbor? The lack of direct physical evidence is a quiet counter-argument. Beyond the texts and artifacts, there are practical doubts. Could this delicate procedure work on the deck of a longship? The ship is pitching, the waves are crashing, your hands are cold, maybe wet. You're trying to hold a clear crystal steady, rotate it slowly, and judge a minute difference in brightness between two faint images in a gray sky. It requires immense concentration. Critics ask, is this realistic for a crew fighting for survival in a North Atlantic storm? Or is it a laboratory idea, beautiful under controlled conditions, but impractical in the chaos of the real sea? And perhaps the most profound question, did the Vikings possess the conceptual framework to understand polarized light? We explain it with physics, with wave theory. They explained their world with myth, with the deeds of gods. Could they have discovered this property purely through observation and trial without the science? Absolutely. Many technologies were perfected long before the theory behind them was understood. But skeptics highlight this cognitive leap. To go from noticing a crystal makes double images to systematically using that property to decode the sky's hidden polarization pattern. That's a sophisticated chain of reasoning. It suggests a culture of intense empirical experimentation. The question isn't whether they were capable. The question is whether the historical record strongly suggests they did it. Engaging with these doubts isn't a weakness, it's a strength. It moves us from a simple, romantic tale into a much richer investigation. We're not just looking for an answer. We're weighing evidence, considering context, confronting the limits of what we can truly know about the past. This balanced pursuit, this willingness to sit with uncertainty, is what separates legend from history. It's what makes the search for the Sunstone so compelling. It forces us to look harder, think deeper, and appreciate the profound mystery that still surrounds those who sailed into the grey. The idea of reading light to find a path, it's not something that only happened in the North Atlantic. Wherever people met the sea, they developed their own languages for navigation. They learned to listen to the ocean's deeper rhythms. In the Pacific, Polynesian voyagers undertook journeys that are hard to even imagine now. They crossed thousands of miles of open water, finding tiny islands without any instruments we would recognize. Their genius was a kind of literacy, a literacy of the environment. They memorized the star paths, the specific stars that would rise and set over each destination. They watched the ocean swells. They could feel how those swells refracted around islands, creating patterns in the water. Patterns you could read like a map from many miles out. They observed the flight of birds, the drift of clouds. For them, the sea wasn't a blank space. It was textured, alive with signs. They didn't use calcite crystals, but their method shares a core philosophy with the Sunstone. They found guidance in phenomena invisible to the untrained eye. They decoded the world's hidden signatures. Further north, in the Arctic, there are stories among the Inuit. Tales of guiding stones, sometimes called sunstones in later tellings, used to find direction in the endless white of the tundra or the flat light on the ice. These stories speak of using translucent stones, maybe mica, maybe quartz, to observe the sun's position when the glare made the horizon vanish. The specifics are different from the Viking context, but the underlying impulse is the same. It's that human drive to take something from the land, a stone, a piece of ice, an observation of wildlife, and forge from it a tool for orientation. When the world becomes a uniform, featureless expanse, the mind looks for the subtle gradients, the faint patterns that betray some order. These parallel stories from across the globe, they don't prove a shared technology. There's no evidence of a single, ancient sunstone tradition passed between cultures. Instead, they reveal something maybe more profound, a recurring theme in human ingenuity when faced with the immense challenge of navigation. The challenge of not being lost. Different cultures, in complete isolation, arrived at a similar principle. Look deeper, read what is not immediately obvious, use the innate properties of the world to reveal what is hidden. The Viking with his Iceland Spar, the Polynesian master reading the refraction of waves, the Arctic traveler interpreting light on ice, all were engaged in the same fundamental act. They were translating the silent language of the earth. This comparative view, it lifts the Sunstone from a curious Nordic artifact into a symbol of a universal human endeavor. It places the Viking navigator within a global tapestry of indigenous innovation. It suggests that the discovery of such phenomena isn't a bizarre one-off. It's a natural product, acute observation married to dire necessity. When survival depends on knowing where you are, you learn to see the world with different eyes. You learn to ask the environment questions no one thought to ask before, and sometimes the answer is held in the light, waiting in a clear stone, or written in the path of a distant swell. This shared legacy of wayfinding, it reminds us, long before satellites and GPS, humanity was already networked, not by technology, but by a common, relentless curiosity. A curiosity to solve the oldest puzzle of all, how to find our way home. The crystal's real power might not have been what it showed, but what it meant. On a longship, the line between a tool and a charm was thin. The world was ruled by unpredictable gods. A sudden squall could be the wrath of Njörður. A hidden sun might feel like a trick from Odin. Certainty was rare. Fear was the real enemy on those voyages. Fear could unravel a crew faster than any storm. So the Sunstone was more than a mineral. It was a psychological anchor. Picture the fog closing in for a third day. The water looks the same in every direction. Supplies are low. Doubt starts to whisper. That's when the navigator takes out the stone. The crew watches. They see him do this quiet ritual. He holds the crystal to the sky, turns it slowly. His face is a mask of concentration. Then he nods. He points a direction. He says, "The sun is there. Our course is true." That simple act changed the feeling on the ship. It replaced guesswork with a declaration. It turned the unknown into the known. For the crew, it wasn't about the physics of polarized light. It was about seeing their leader commune with a hidden order. He was pulling truth from the gray chaos. That inspired a deep confidence. It was a shared belief, backed by a physical object, that they were not lost. That the gods of sky and sea had not abandoned them. That confidence was a tangible resource, as vital as fresh water or a fair wind. This mix of technology and belief was central to the Viking mind. They didn't separate science from spirituality. To understand the sun's path was to understand the work of the gods. A tool that revealed that path was a key to divine intention. The Sunstone lived in that sacred space between invention and revelation. It was a practical answer from observation, and also a symbolic key to mastering a universe full of spirits and omens. This psychological edge can't be measured in a lab, but it might have been the most crucial factor. It let them press on when others would have turned back. It built the resilience needed to sail beyond the sight of land, into the realm of myth, and then into history. So the Sunstone worked on two levels. It calibrated their course on the ocean, and it steadied their minds against the immense, whispering unknown. One enabled the journey across water. The other enabled the journey across fear. Lab precision is one thing, but the open ocean is another. To really understand the Sunstone, you have to take it out there, and that's what's happened in recent years. A few researchers and sailors, they built replicas based on that Alderney crystal. They studied the old methods, and then they cast off. They tried to navigate like the Vikings, using just the sky and a piece of stone. One of the big tests was in 2013. A team of Hungarian scientists and archaeologists, they set out on a voyage. They sailed a replica Viking ship with a replica Sunstone made of Iceland Spar. Their mission was to follow a course in the North Atlantic from Norway toward Greenland, using the crystal as their main guide. This wasn't a simulation. This was the real environment, the same cold, the same cloud, the same water. The challenges started right away. Salt spray was a constant problem. A film of salt on the crystal would scatter the light, ruin the polarization reading. The navigator had to keep the stone clean, wiping it with a soft cloth all the time. Then there was the motion of the ship, holding a small crystal steady on a rolling deck, while trying to judge tiny differences in brightness between two faint images. That took immense concentration. A very steady hand. It wasn't a skill you could pick up in an afternoon. The team said it took days of practice just to get consistent readings. You had to learn to brace against the ship's rhythm, find moments of calm in the swell, develop a feel for the correct alignment. It was a physical art, demanding. One person on that voyage described it as transformative. He said it changed his relationship with the sky. You stop seeing the cloud cover as just a gray blanket. You start to see it as a textured dome with areas of slightly different light, different character. The crystal forces you into deep observation. You're not just looking, you're interpreting. And when you finally catch that balance point in the stone, when the twin images merge into equal brightness, the feeling is one of connection. You've pulled a fixed truth from a shifting world. These modern voyages are the proving ground. They move the Sunstone from a physics experiment into practical seamanship. They answer the question about whether it's feasible on a pitching deck. The answer is yes, it's possible, but it's difficult. It requires skill, patience, deep familiarity with the tool, and that might be the most valuable insight from these replications. They show that the Sunstone wasn't a magic wand. It was a specialist's instrument mastered through long apprenticeship. Its value wasn't in making navigation easy. Its value was in making navigation possible when all other methods failed. In the thick of a North Atlantic haze, with no landmarks and no stars, that difficult procedure with a crystal might have been the only thread connecting a ship to its destiny. These modern sailors with their replicas, they're not just testing a theory. For a moment, they're feeling the weight of that responsibility in their own hands. That clear crystal from a shipwreck, it's not just a relic, it's a direct ancestor to the screen you're looking at now. The principle the Vikings might have used detecting polarized light is woven into our world. It's the fundamental technology behind every LCD screen. In your phone, your television, your monitor, there's a polarizing filter. It controls light the way the Iceland Spar did. It blocks certain orientations of light waves to make the images we see. That same principle is in camera filters, in sunglasses that cut glare, in instruments that study the atmospheres of distant planets. The Sunstone was our first intuitive grasp of a powerful natural phenomenon, and we've built a civilization on it. That connection changes the ancient tool. It wasn't a dead end of superstition. It was a pioneering step in a continuous quest to see the unseen and to navigate by it, and that quest is accelerating now into places that sound like science fiction. Think about modern navigation. GPS is a miracle, but it has a critical weakness. It relies on signals from satellites. Those signals can be jammed, they can be spoofed. Or they're just unavailable deep underwater, underground, in the depths of space. So researchers are looking back to a core idea, the same one that guided the longship. Navigation without an external crutch. They're developing what some call a quantum compass, a device so precise and self-contained it could guide a submarine under the Arctic ice for months without ever surfacing for a GPS fix. How it works, at its heart, it uses quantum mechanics to measure the Earth's magnetic field with astonishing sensitivity. It doesn't receive a signal. It reads the fundamental fabric of the environment, just as the Sunstone read the polarization of the sky. The technology is light years ahead, but the philosophical lineage is direct. Both tools find truth in the invisible constants of our world. Both seek orientation from sources that can't be blocked or deceived. This lineage, from crystal to quantum sensor, changes the story of the Sunstone. It moves it from the margins of mythology to the center of a profound human narrative, the story of our drive to solve the essential problem of place. To know where we are in a vast, often featureless universe, the Viking navigator, holding his spar up to a gray sky, was engaged in the same fundamental act as the physicist tuning a laser in a lab today. They are both asking the environment a question and listening for a subtle, truthful answer. The tools evolve, the underlying quest does not. That perspective transforms the Sunstone. It's no longer a curious footnote about the past. It's an early, brilliant chapter in our ongoing manual for exploring the unknown. It shows the most futuristic solutions often have roots in the deepest observations of the natural world. Next time you look at a screen, remember the light it controls, and remember the first person to think of using light that way might have been standing on a wooden ship in a cold sea, turning a stone in his hand and seeing a path no one else could see. Their world was a world of gray, a constant, deep gray. The North Atlantic routes they sailed, these weren't just empty spaces on a map, they were environments. Specific, relentless conditions. For months, the sky wasn't blue, It was a low ceiling of cloud, a dense, luminous gray that diffused the light. It erased the horizon. Fog banks would roll in without warning. They'd swallow a ship whole. The universe would shrink to the sound of water against the hull and the damp chill in the air. In the long summer, they had the midnight sun, a sun that skimmed the horizon but never truly set. It cast a directionless amber glow. In the deep winter, darkness reigned. Broken sometimes by the aurora borealis, those ghostly green curtains writhing silently overhead, beautiful but useless for finding a bearing. That was the canvas. That was the navigational reality. Every tool they used had to function there. In that world of muted light, of hidden reference points, a magnetic compass, even if they'd had one, would have been nearly useless. They were sailing perilously close to the magnetic North Pole. In those latitudes, a compass needle doesn't point north reliably. It dips, it wobbles. It becomes sluggish, confused. It points toward the ground as much as toward the horizon. So the Viking navigator couldn't rely on a needle drawn to a rock in the Arctic. He had to rely on the sky itself, but the sky in this place was a master of deception. The sun could be present but invisible, its light scattered into a uniform, shadowless haze. This is where the Sunstone's genius becomes clear. It wasn't a general-purpose tool invented in a vacuum. It was a bespoke solution, engineered by necessity for this specific, difficult environment. The very conditions that broke other methods, the pervasive cloud cover, the polarized light scattered by all that moisture, were the conditions that made the Sunstone work. The fog wasn't just an obstacle, it became the medium that carried the signal. The crystal decoded what the weather did to the light, and that reveals a deeper truth about innovation. Technology doesn't just advance, it converses. It evolves in a continuous dialogue with the landscape. The Vikings didn't conquer the North Atlantic in spite of its harshness. They did it by learning to speak its language. They listened to what the gray sky was actually saying, and they fashioned a key to understand it from the very stones of their homeland. Their achievement seems even more remarkable when you see it not as a triumph over nature, but as a profound collaboration with it. They didn't fight the fog. They learned to read it. The clear crystal has traveled far beyond the old stories. It's in our living rooms now, a star in its own right, a fixed part of how we tell Viking stories today. In big historical novels, you'll often find it, a sunstone held in a navigator's rough hand during a storm scene. It becomes this symbol, a piece of hope. A sign of cleverness. Documentaries do it too. They have these reenactments, an actor looking through a piece of Iceland Spar, and a voice explaining the science with graphics. And then in video games like Assassin's Creed, where you can use a sunstone to solve a puzzle, the game teaches you a bit of ancient tech through play. These versions cover a wide range. Some try for real accuracy. They work with historians. They want the look right, the function right. Others take that creative step. They turn the stone into something more magical. Maybe it glows, maybe it shows hidden paths. That range is interesting. It shows us wrestling with the same line. The line between what was a real tool and what feels like a legend. This cultural embrace has a deep effect. For most people, their only meeting with a sunstone is inside one of these stories. That's a powerful thing. It builds awareness, it starts curiosity. A player might stop and wonder, did that really exist? And then go look for answers. Read an article, watch a video. So popular culture works like a gateway. It pulls a quiet academic debate into the mainstream. It makes the past feel close. Something you can touch, something exciting, but there's a cost. For the sake of a good plot or a fun game, complexity is often lost. The slow skill it took to use the stone. The spray of salt, the unsteady deck, the years of learning, those gritty details can fade. What's left is a cleaner symbol, a Viking super tool almost. That glamour can build a new, simpler myth. It can make it seem like the historical question is answered. that we know they used it this exact way, when really we're still looking at pieces of evidence. We're still weighing them, which leaves a quiet duty for the people making the stories and for us watching or playing. The goal isn't to take the magic out. It's to see where the magic actually lives. The real wonder isn't in a glowing crystal on a screen. It's in the thought that people, just by watching and by daring, might have learned to read the sky with a piece of rock. A good story opens the door, but it's the history, the evidence that asks us to come in and sit down, to look closer, to see the human achievement behind the legend. The Sunstone's path, from a few words in a saga to a button you press that shows its lasting power. It reminds us, the tools we use to dig into the past matter just as much as the tools they use to navigate their world. This move from saga to science, it gives you more than an answer. It gives you a different way to look back. The Sunstone, it's really the perfect case for teaching how science history works. Because it won't stay in one category. To make sense of it, you have to draw from all these different fields. The physics of polarized light, the geology of that crystal Iceland Spar. The archaeology, what's been found in shipwrecks, those bearing dials. Even the literary work, reading the old Norse poems, all of it has to connect. That back and forth between disciplines, that's what real discovery is. It shows you that progress, it isn't just a straight line from not knowing to knowing. It's this messy, beautiful conversation, a conversation that stretches over centuries across cultures, and that conversation, it can happen right in a classroom. Think about a simple experiment, a piece of calcite, a polarizing filter from an old LCD screen, and a flashlight. Students can see the double image themselves. They can watch the crystal's magic appear, then disappear just by turning the filter. They can feel that moment of discovery, the same moment a Viking navigator might have felt centuries back. It turns a distant legend into something tangible, a physical principle they can hold in their hands. That hands-on approach, it does something deep. It actively takes apart this old, stubborn idea, the idea of the so-called Dark Ages. That label, it suggests a long gap in human thought, a time of superstition sitting between the fall of Rome and the Renaissance. The Sunstone story, it shatters that completely. It shows a period that wasn't dark. It was a time of intense, sophisticated observation, of practical genius. The Vikings, they weren't just waiting around for the Enlightenment. They were running their own rigorous experiments with the materials they had in their world. They were empirical scientists, even if they would have used different words for it. They observed a phenomenon. They developed a tool to use it, and they used that tool to do what seemed impossible. Teaching this story, it empowers students. It lets them see historical people not as primitive ancestors, but as intelligent, resourceful problem solvers. It changes the question from what did they not know to what did they know and how did they figure it out. That shift in perspective, it changes everything. It turns history from a list of dates and names into a living investigation, an investigation into human ingenuity. The past becomes a place full of innovators. Their methods, they're whispering to us, waiting for us to learn their language. The Sunstone is one key to that language, a key that unlocks more than a nautical secret. It unlocks a deeper respect for the brilliant minds who sailed into the gray. The search isn't over. The evidence is strong, but it's still circumstantial. There are a lot of questions left. To move from a theory to a fact, what would it take? What's the missing piece? For an archaeologist, the dream find would be a clear Iceland Spar crystal. Found in an undisturbed Viking Age site, a ship burial or a navigator's grave, and this crystal would show signs of its use, not just polished but with specific wear. Microscopic grooves from being held, rotated between thumb and fingers for years. That kind of physical testimony, linked to a person of the sea, would change everything. There's also hope in looking again at what we already have. New analysis techniques are more sensitive now. Scientists could take artifacts in museums, dials, wooden ship fragments, stones once called decorative, and put them under new scrutiny. Look for microscopic residues, abrasion patterns you can't see with the eye, maybe traces of organic material from a leather pouch, a technique called use-where analysis used on stone tools could be applied to a crystal, to see if its surface tells a story of deliberate, repeated handling. The literary trail might still have secrets. New textual analysis with digital tools to cross-reference thousands of Saga manuscripts could find a description we've missed. A more detailed account of the Solarstein buried in a lesser-known text, waiting for the right scholar to connect it. This search is a collaboration. It's not just archaeologists, it's physicists modeling light scattering in ancient atmospheres, material scientists probing the atomic structure of artifacts, historians and linguists parsing every syllable of the old poems. Each field brings a different lens. Together, they triangulate on the truth. Every new piece of evidence, every angle of study brings us closer. The goal isn't just to win a historical debate. It's to recover a lost piece of human ingenuity, to appreciate the cognitive leap those navigators made. Each clue adds another stroke to the portrait of the Viking mind, a mind that saw a tool in a clear stone and a map in a blank sky. The pursuit itself, this blend of curiosity and science, honors their legacy. It means their story is never truly finished. It's always alive with the possibility of a new discovery, waiting beneath the next wave or hidden in the next line of an ancient story. We know the Vikings could navigate across open ocean. We know from physics that a crystal like Iceland Spar can detect polarized light, and that can show you where the sun is. There are a few mentions in the sagas of a Solarstein, a Sunstone, as a tool, and we have a physical object, the Alderney crystal, found on a later shipwreck that proves the principle was known and used. So those are the facts. They're solid, but around those facts a story has grown, a story where every captain had one of these stones, where it was this magical primary tool they used all the time under every cloudy sky. Where the stone itself might have glowed, that's the legend, and it's a cleaner story, a more dramatic one, but it starts to cover over what was probably more complex and more interesting. Think of the practical reality. These crystals weren't just lying around everywhere. Using one correctly took skill and a lot of patience. It's much more likely they were a specialized instrument. Maybe one or two per fleet, carried by the most experienced navigators and only brought out when everything else failed. It wasn't their everyday system. It was the backup, the tool for the worst possible conditions. Their real genius wasn't in one crystal, it was in the whole system. The Sunstone was just one piece. One piece in a huge mental library of knowledge: the stars, the flight patterns of birds, the feel of ocean swells, the winds, dead reckoning. To fixate on the stone is to miss everything else. It turns a whole culture of deep environmental understanding into just a gadget. And looking at it this way, critically, it doesn't make the Sunstone less. It makes the whole context more. You see the technology for what it likely was. A brilliant, hard-won solution for a specific, extreme problem, not a magic wand. A testament to observation and to adaptation. When you clear away that anachronistic glow, you see the real people more clearly, navigators who were scientists of their world, who combined tools and tradition and courage to do what no one else was doing. Their reality, without the exaggeration, is more impressive than the myth. Because it's what actually happened. Archaeology runs into a hard reality. The past doesn't preserve everything the same way. It keeps what lasts: a sword, a brooch, pottery. These are made to endure. They sink into the soil and wait, but the tools of everyday life, especially from organic materials, they're different. They're made to be used, not to last. And that creates a gap, a preservation bias. It shapes the stories we can tell. Think about the materials. That wooden disc from Uunartoq only survived because of specific, lucky conditions. Buried, protected in the cold, but a navigator's main toolkit wasn't metal. It was knowledge, it was perishable things, the carved notches on a tally stick, the worn leather of a star chart pouch, the ship itself, which would rot away unless it was buried or sank in just the right place. Those are the first things to go. They return to the earth. Then there's the Sunstone, a clear crystal of Iceland Spar. Imagine one used for years, then lost. It falls into the mud of a floor or slips between the planks of a ship into the silt. Centuries later, an archaeologist brushes away the soil. What does it look like without any carving, without a mount, without a rune that says navigation tool? It's just a stone. A beautiful, clear stone. But in a world where people used crystals for decoration, for games, just out of curiosity, you can't label it definitively. Not by sight alone, the context is everything, and that context, the navigator's hand, the ship's deck, the moment of use, it vanishes in an instant. That's the dilemma. The most elegant tools are often the most fragile, the most organic, the least likely to announce their purpose to the future. We find the warrior's sword because it was placed in his grave with ceremony. We rarely find the sailor's crystal because it was a working tool, lost by accident or passed down until it was worn out and discarded. Its value was in its function, not its permanence. So the absence of a definitive Viking sunstone, it's not a verdict. It's a condition of the search, a reminder that history isn't just what survives. It's also what we piece together from whispers, from shadows, from the empty spaces where something vital once was. The lack of a crystal in a labeled box doesn't mean it didn't exist. It means we have to be cleverer in how we look, reading the indirect evidence, listening for echoes of its use in other surviving objects, like that wooden disc that needed it. The silence of the ground, that's not a story of absence. Often, it's the loudest clue of all. That empty space where the tool should be, it points to something deeper. Their navigation wasn't just a set of skills, it was a way of being, a philosophy. The Old Norse had a word for it, wayfinding, but it meant more than plotting a course. It was a dialogue with the world, guided by a sense of fate, what they called orlurg. This was the underlying pattern, the web of destiny woven at birth. You couldn't escape your orlurg, but you could meet it with courage. Sailing into the unknown grey was an act of embracing that fate. It took a relentless will, a personal courage they called drengskaper. The voyage was a physical form of a spiritual stance, and in that light, the Sunstone isn't just a crystal. It becomes a symbol, a tool to find a hidden, fixed point in a chaotic sky that mirrors their deepest myths. Think of Odin, the All-Father. He sacrificed his eye at the well of Mimir to drink from hidden wisdom. He gave up one kind of sight to gain another, to see the patterns beneath the surface. The navigator, with his Sunstone, was on a similar quest. He was sacrificing the easy view, the visible sun, the clear horizon, to gain a deeper sight. To perceive the hidden order in the chaos, he was reading the orlurg of the sky itself. That turns wayfinding from a practical task into something sacred. It was how they oriented themselves, not just on the ocean, but in the cosmos. Their tools were extensions of this. The bearing dial tracked the sun's ordained path. The Sunstone revealed its hidden presence. The stars were the fires of the gods. Every reading was an act of listening to a world they believed was alive. So we have to ask a question, one that goes beyond history. In our age of instant GPS, where a satellite tells us exactly where to turn, have we lost something? That innate, cultivated connection to the environment. The Viking approach required a profound harmony with nature. It demanded you pay attention to the light, the wind, the water, the wildlife. You had to become part of the system to understand it. Our modern tools, for all their brilliance, often do the opposite. they insert a layer of abstraction between us and the world. We follow a blue dot on a screen, but we might not feel the shift in the wind that signals a storm, or recognize the bird that tells us land is near. That Viking philosophy holds a quiet relevance for our disconnected age. It reminds us that true orientation isn't just about coordinates, it's about relationship. It's about developing the skill to listen to the subtle language of the world, to find our place within its patterns. That's a kind of wayfinding we might all need to find again. That journey with the crystal doesn't stop with the old stories. It goes on into the way we think about Vikings now. The Sunstone has turned into this strong cultural symbol. It's actively changing their identity in the modern world. For a long time, the popular picture was pretty one-dimensional, just fierce raiders with those horned helmets, which actually came from opera costumes much later. But the Sunstone adds another layer. It suggests curiosity, it suggests intellect, a sophisticated reading of the natural world. This tool turns them from being only warriors into being pioneers of science and exploration. It finishes a more complete portrait, one where the axe and the crystal could exist in the same culture, a culture that was capable of conquest and also discovery. You can see this shift all over Scandinavia. The Sunstone shows up in national branding, in museum exhibits made for a new generation. It's a centerpiece in displays about Viking technology, usually right there next to the longships. The message is straightforward. Our ancestors were innovators. They were master navigators who solved hard problems with what they had. For places like Iceland, Norway, Denmark, this isn't just about the past. It's about building a modern identity based on resilience and ingenuity. The Sunstone becomes a point of pride, a physical link to an age of fearless exploration that still means something now. In education, the Sunstone works as a perfect gateway. Teachers use it to get students interested in STEM. A lesson can go from a history book to a physics experiment in one move. Students can look at polarization, light, the scientific method, all through the story of a Viking navigator. It makes abstract ideas feel personal and tied to history. This use in schools shows how research doesn't just stay in journals. It filters out, it changes how we teach, and it changes how young people connect with their heritage. They're not just learning about raids, they're learning about solving problems under extreme pressure. This modern embrace proves something important about cultural heritage. It isn't a fixed set of facts locked away, it's a living conversation. Every new discovery, every new interpretation actively changes how a society sees its own story. The Sunstone theory, debated by historians and tested by physicists, has given the 21st century a new symbol, a symbol of Nordic innovation. It provides a narrative tool that links modern societies to their ancestors' intellectual adventures. It tells us our forebears weren't just living in their time, they were actively trying to figure it out. So the story of the Sunstone is also the story of history itself. A field that's always being rewritten, reimagined. The past isn't a closed book, it's an open landscape, and every new tool, every new question lets us see a different path through it. The Sunstone, once just a mention in a saga, now shines a light on a much richer Viking age, and by doing that, it reminds us that our understanding of who we are is always beautifully being built. The evidence doesn't lead to one clear answer. It points toward a quiet probability. The most balanced conclusion is this: it's highly plausible that some Viking navigators, the masters of their craft, used light polarizing crystals like Iceland Spar. As a specialized tool, this wasn't a magic stone every sailor carried. It wasn't an infallible device. It was a clever application of an observable phenomenon. A navigator, over years of watching the sky, might have noticed a clear stone behaved strangely on certain cloudy days. He might have experimented, learned to correlate its shifting light with the sun's hidden position. honed that into a repeatable technique. This knowledge, precious and difficult, would have been passed down carefully, perhaps only within certain families. To the most promising apprentices, the Sunstone was a supplement, a brilliant piece in a much larger toolkit, integrated into a broader suite of skills: dead reckoning, bird lore, wave reading, stellar navigation. It was the tool you reached for when the primary methods failed, when the world turned to a uniform gray and the usual signs vanished. In that moment, the crystal offered a thread of certainty. A way to take a single, crucial bearing, to re-anchor your mental map of the world. This synthesis satisfies both science and the historical record. The physics is undeniable, the crystal works. The artifact from the Alderney shipwreck shows the principle was known. The sagas, while sparse, treat the solarstein as a tangible object. Yet the archaeological silence from the Viking Age itself reminds us of its likely status. A perishable, organic tool of the trade, not a ceremonial object meant to endure. This probable truth feels more satisfying than any legend. It gives us real people. Pragmatic, observant, brilliant problem solvers who looked at a clear rock and saw not just a stone but a key to the sky. They didn't have our understanding of polarized light. But they possessed something just as powerful, a deep, patient conversation with their environment. They learned to ask the right questions of the world. And to listen for the subtle answers. That's the resolution, not a definitive yes or no, but a resonant, credible maybe that honors their ingenuity. The Viking Sunstone stands as a testament to human curiosity. The drive to see what is hidden, to find a way forward, even when the path is lost in the mist. Our trip through myth and crystal and science doesn't end with one answer. It ends with a different kind of understanding. The Viking Sunstone is a story about possibility. It shows a world where the line between a tool and a legend was very thin. Where a clear piece of rock could become a key to the sky. That wasn't magic in the fairy tale way. It was the magic of the human mind, seeing something subtle in nature and asking, what can I do with this? That curiosity is a thread. It connects the navigator on his longship to the physicist in her lab, to anyone who's looked at the world and wondered how it works. The Sunstone, whether it's proven or stays in the realm of the probable, stands as a testament to human ingenuity facing the immense and the unknown. It challenges the old, simple picture of the past. It asks us to see ancient peoples not as primitive but as resourceful, as brilliant problem solvers who used every clue their environment offered. They remind us that innovation isn't always about inventing something new. Sometimes it's about seeing the extraordinary use in something the world has always held in plain sight. The real lesson isn't about a single crystal, it's about a way of thinking, a way of navigating that blended sharp observation with deep tradition and courage with practical science. It's a philosophy that feels relevant today. In our age of instant digital answers, the Sunstone story invites us to reconnect with a more fundamental kind of wayfinding. To cultivate our own ability to read the subtle patterns around us, to find our bearings not just from a screen, but from a thoughtful engagement with the world. History's greatest secrets are often like that. They don't shout, they whisper, they wait for the right light, the right question, the right moment of curiosity to reveal their truth. The Sunstone's light, whether literal or symbolic, still guides us. It illuminates a past that is more intelligent, more nuanced, and more inspiring than we imagined.